Hi, and welcome back to Python Deep Learning for Beginners. We're beginning a new section today talking about object detections in CNNs. In this section, we're going to take a look at two different topics. Number one, building a CNN to detect general images. And number two, how we can train and deploy this CNN on a cluster. Building a CNN to detect general images. In this video, we're going to take a look at number one, what is image classification? Number two, what dataset do we need for image classification? And number three, what is a CNN architecture that we can use to classify images? Let's dive right in. To introduce the image classification task, let's look at a very popular public image dataset that is also used as a benchmark in deep learning enabled computer vision called CIFAR-10. In this dataset, there are many classes as well as random images associated with each class. The task of image classification is if I give a neural network the first top left image, it should tell me that this is an airplane. If I give him the second from the top image on the left, it should tell me that it's an automobile. If I give this neural network a picture of a dog, as what we can see in the sixth row of this example, it should give us the label dog. So how do we train a neural network that can do this? In this dataset, it consists of 60,000 32 times 32 color images in 10 classes. In each class, there are 6,000 images per class. We can use the default split of the datasets from 50,000 training images and 10,000 test images. The dataset is divided into 5 training batches and 1 test batch, each with 10,000 images. The test batch contains exactly 1,000 randomly selected images from each class. So the class is completely mutually exclusive. There's no overlap between automobiles and trucks. Automobile includes sedans, SUVs, and things of that sort, and then truck only includes big trucks. What this means is the neural network can very nicely see that using CNNs to construct representations that are non-ambiguous. So with this characteristic in the datasets, it's easier for our neural network to train itself to distinguish each image into one of the 10 classes. To download this dataset is very easy. All we need to do is click on the Python version and download it. So we talked about image classification and the dataset we're using for image classification. Now let's have a brief look at what CNN we can use to classify this image. I'm going to go into my Jupyter Notebook again to show you one example architecture in Keras that we can use. If you follow me to the Jupyter Notebook, there will be a Jupyter Notebook called Chapter 8, Object Detection Using CNNs. In this Jupyter Notebook, we first in line 1 import Keras, and then in line 2 to line 4 we import the sequential model, a dense layer, a dropout layer, a flatten layer, and then some convolutional layers like convolutional 2D layer, and a max pooling 2D layer. In line 6, we first start a new model by using the sequential constructor and assigning this output to the model. We then add one convolutional layer, specifying that the input shape being 32, 32, 3. Now you may wonder why is the input shape 32, 32, 3. Recall that in our datasets, each image is 32 pixels times 32 pixels. And because this is a color image, it has 3 channels, red, green, and blue. Because this is the first layer, we need to specify input shape, but as you can see, the second layer of convolutions do not need an input shape. After 2 convolution layers, we'll create a max pooling layer, and the pool size is 2 times 2. To prevent overfitting, we then add a dropout layer with a 25% probability of dropping out. We then move on to another set of convolutional layers, this time with 64 filters. After 2 of these convolutional layers, we again arrive at a max pooling layer with a pool size of 2 by 2. To prevent overfitting at this stage, we add another dropout layer with 25% probability of dropping out. We then add a flatten layer to flatten all the neurons, and we feed it into a dense, fully connected layer of 256 neurons. We add another 50% dropout layer, feeding this dropout layer into a fully connected layer that outputs 10 neurons. The reason why we have 10 neurons in this last fully connected layer is because we have 10 classes in our datasets. Finally, we call compile using our familiar categorical cross-entropy loss and the SGD optimizer. Now that we've compiled the model, all we need to then do is call model.fits. For guys who come from a scikit-learn background, you would find this syntax very familiar. Here we need to fit in the xtrain and ytrain variables, along with the batch size that we want the model to use, and the epochs that we're using. Finally, we can evaluate the model using the test data and input this evaluation into score. And there we have it. It's very, very simple. We've just learned, number one, what is image classification? Image classification is, given any image, we want to label it correctly respect to what the content is in the image. A dataset that we need for image classification contains many, many images neatly divided into 10 classes, so the neural network can build a representation of what each class looks like. To use a CNN to classify these images, we use Keras to create a generic CNN architecture that is composed of CNN layers, max pooling layers, dropout layers, and fully connected layers.